A week ago, this 21-year-old truck with nearly 300,000 miles looked like this. And now it looks like this. This is a tandem damper variable pushrod suspension, and I believe this is the first pickup truck that I've seen online or in person to have a dampening system like this. It took me about a week of fabrication, but I had the original idea 4 months ago. And in those 4 months, there's been hundreds of hours of brainstorming, CAD, software, planning, labor, everything from conception to doing the actual build. There was dozens of unforeseen failures, bunch of quick fixes, plenty of moments where I thought I was stuck and I couldn't figure out how to fix it. And right now, there's two things that are wrong with it. One damper has lost about half of its damping, and its rebound is not as strong as it should be. And that's a result of driving it roughly as it was intended to be driven during testing and validation. And the second thing is that there's no fender guards or flaps to protect my rear window from huge rock chips or window cracks. And I can't really continue testing and validating until we fix that. So today we're gonna create a small fender flap for both wheels, and I'm gonna show you how I do that while I talk about this project more. So I've pretty much always been obsessed with everything automotive and everything mechanical since I can remember, just doodling sketches in my notebook since I could pick up a pencil. But once I got into my senior year of high school, I started to actually become smart enough and acquire enough knowledge to actually start coming up with my own unique ideas and almost bringing them to actual fruition. When I graduated, I spent a lot of time and a lot of hard work teaching myself some basic manufacturing and building on the skills that I had learned in high school. I took, manufacturing classes in high school. I learned CAD. I did all those kinds of things. And because of that, I managed to build some things that people really thought wouldn't work. And they actually did work. One of those being a 3D printed catch can from nylon carbon fiber composite. And the other being 3D printed water methanol injection nozzle that's pneumatically actuated. The whole point of this video is to demonstrate that my engineering capabilities, that my manufacturing capabilities, that my fabrication capabilities are actually up to snuff. And I want people to see that I'm very passionate about what I do and that I'm very good at what I do. I want to prove to the world that I'm capable in this domain, and I want to make my dream something that it doesn't have to be a dream. I want to be able to make money from this. I want to be able to provide with this. I want to be able to pursue this unapologetically, and that's what the point of this video is. I'm going to walk through different stages of this build, everything from, the initial idea 4 months ago to how it is today with one broken damper and about 100 miles in testing on it. So my dream one day is to build my own car. And I figured if I want to build my own car, I should probably start with something fabrication related and something that's not too difficult to do as a first project. And I decided on suspension. So this truck, it's my first truck, it was a hand-me-down, and it has quite a few miles on it. As I said, about 300,000 nearly now. So I figured, hey, I got this truck for free. I'm going to use this as a testing platform to see, what can I do? How can I do it? And, validate the ideas I have and build on those skills I need to, do what I want to do. So one of those ideas was this kind of decoupled shock absorber system. And I had the idea of, having these two tandem shocks like strapped together and trying to package it within, the original shock mounts. And at the end of the day, that was like way too large of a scope. And if I couldn't actually get a concise idea for what it needed to be. I'm sure I could have done it that way, but at the end of the day, I'm working with a budget here, and I'm working with a time budget, I'm working with a money budget, and I'm working with a mental budget. So I figured, no, the easiest thing mentally and pocket-wise to do was to get 2 dampers, one of them kind of bad, one of them decent, and use a mechanical linkage to get the best of both worlds out of them. So that's where I came up with the idea of having this mechanically adjustable rocker arm in between them. I've only been welding for about a month after I graduated, and I spent all that time refining those manufacturing skills and building, real stuff, testing real stuff on this truck. It actually landed me a job in the aerospace industry here in Austin. I did everything, from assembly to nesting for $1 million laser cutting machine to handling the parts myself, anything from basically even just deburring to DFM and DFA assembly and getting that to the customer and working with fab teams and everything. And I was really good at what I did. I adapted really quickly, and that job helped me build the skills and the confidence, most importantly, the confidence that I needed to pursue something like this. And one of the things I learned in that job was MIG welding. I figured I had like a 30-minute lesson in MIG welding, but I figured, if I can do this, I can probably figure out how to do some other stuff, right? So I bought a little cheap Amazon welder, and I figured that this project in the avenue that I took this project down was the best option for what I wanted it to be. For the goal, it was to build credibility, to build an image. I wanted something that's visual, that's striking, that shows motion, that shows capability. And I wanted that capability to in turn create credibility, because if people see that, he can build that, maybe he can build a catch can, and maybe I should buy it. I ended up leaving that job for multiple reasons. The biggest thing was the management and the sense of achievement. The way that the work was structured there, I never felt like I was achieving anything, and there wasn't a dopamine loop or a reward loop there for me. So I got burnt out really fast. And on top of that, management would always curse at me, yell at me, over the most insignificant things that at the end of the day, I did those things that way because that's how I performed the best. And they couldn't deal with those quirks, and I couldn't deal with the treatment, the cursing. So I cut things cleanly. I literally just wrote a letter at the beginning of the week, and then by the end of the week, I was getting yelled at one more time. And I was like, this is the day. Left that letter on my boss's desk, and I never came back. As difficult as it was, I did come out learning a lot and being way more capable than I was beforehand. And because of that, I have this project now that I've actually brought from its just conception to having an actual physical working and a fun to drive truck. First of all, I had to remove the bed, and 2, the bed bolts, because Ford decided to make these Torx T50 Pluses, ended up stripping out, and I actually snapped my Torx bit. No matter how much WD-40 I hit these with, no matter how much PB Blast I hit these with, no matter how hot I got these, they didn't come out. So I had to weld these huge nuts to the head of the bolt and then hit those off with an impact. Once I got 2 of the bolts that needed to get out, which took a while, and it was difficult because I had to ground to the bed, clean up some ground points, but didn't take too long. I had to get some people to come over to help me remove the bed, lift it up, and just the frame had a little bit more rust than I thought it would, but nothing crazy. I cut out some stuff that I didn't need, but the original 2005 F-150 frame, the old gen, has like 3 cross members in the rear. So I figured, this is pretty stiff. I don't think I need to change anything there. I designed these rockers in Fusion 360, and I had them cut out by Send Cut Send, and it cost about $120 for all 4 of them. And then those black spacers there, those are 3D printed from nylon 12 carbon fiber. I think it's 10 or 15%. And the compressive strength on that filament per square millimeter is way more than what I needed. Basically just a huge spacer, and it makes the whole rocker it's something that you can disassemble, and that's just more serviceable. It's easier to adjust it, and it gave me a lot more freedom with, you know, the shock absorbers I could use. So that's a test assembly. I used that whole jig. I positioned that on the frame, and I saw, hey, I need to extend this part out. Hey, I can weld that part to the axle. I welded flux core because it was cheap. It was what I had, and it was not too different from MIG. So I welded that's a bracket to the axle, and that's the bracket for the rocker. That's my friend testing the rocker. And I didn't film the rest of the fab and the assembly. That is most of it, because I didn't have any help when I was doing fabrication. I was way too busy and I was way too focused to even pull out my phone and set the camera up or anything, and I'm not very good with the camera. It's time to work away on these like mud flaps. So here, I'm grinding the frame clean for where I'm gonna weld the tabs. And then before I actually weld, I gotta remove the battery. Or not remove the battery, but unplug it. And it actually, you can see in that engine bay, I have that 3D printed catch can that I've been testing, validating, and iterating. 5 iterations on that catch can, and that iteration there specifically has been running for 4 months on that truck, but all of them combined have been running for 6 months. I'm welding the tab that I found in a pile of scrap to the frame. That's going to hold up the mud flaps. Again, flux core was what I had. It was easy. This is what those welds look like. They weren't, you know, the prettiest, most amazing welds in the world, but they definitely were strong enough for what I needed them to be. Again, I'm not a pro. I only have about a month of experience doing this. Is those mud rock flaps. Get that rear window protected. I'm just going to do a little low speed test. I live off of a gravel road, so we're just going to go over some potholes, do a little bit of drifting, and just make sure that nothing hits the rear window. When I was doing the validation that led to that damper losing a lot of its damping, we had quite a few rocks hit the rear window, and that's why I was concerned about this. But I mean, as you can see in the video, I'm only using like a portion of my travel. We still have a lot more room to grow. I mean, that rocker is barely moving and those shocks are barely going. There's still some adjustability there, and obviously there's the shock you're seeing in the video is the one that hasn't lost a lot of its damping. That will be what I fix next. For now, it's not the characteristics of either side. It's not too different. The characteristics of both sides are about the same still. What we mainly lost was a decent bit of rebound strength, but that rebound was only going to kick in during like the very last portions of travel. Pretty difficult to use all the travel because we've effectively added almost a foot of travel over stock. So about all in all, I spent $140 on a second set of the cheapest adjustable dampers I could find. About 120 pushrod laser cut 1/4-inch mild steel bodies. So that's $260 plus about 20 in filament, another $60 in hardware. So I spent about $350 to $400 all in all on this. And I'm going to spend a little bit more, obviously, because we just blew one of the shocks. And I may attempt to cut them open and rebuild them and actually 3D print a valve block instead of rebuilding the shib stack. But the only way I'm going to learn is by actually trying it. So if you made it this far in the video, I just want to say thank you. And I mean, like I said, my goal here is to show the world that I can do these things, that I'm good at these things, and that these are the things that I love. If this convinced you that I'm a halfway competent engineer and that when I actually make something, I put my name on it, then I'd encourage you to look at the things that I make and consider maybe buying one of them. So if you're running a boosted build or you have a high mileage build and you want a catch can, maybe look at mine. They're 3D printed from nylon 12 carbon fiber composite material. They have multi-stage baffling. I spent months upon months and hundreds of hours in CAD and hundreds of hours in testing and breaking them and fixing them and iterating on them and ironing out every single kink. And it's something that I trust, and it's something I put my name behind, and it's something that I believe performs incredibly well. They don't swell, they don't crack, they don't bulge, they won't leak on you. I have that catch can on that truck. And that truck has nearly 300,000 miles on it in the engine bay. And it's literally held in by zip ties. And it's in the worst possible condition. It has a mount that's printed into the body. I just haven't used it. It's in the worst possible condition it could be for it to not break. And it hasn't broken. Thank you. Thank you for watching, and thank you for your time.